Hi everybody, welcome back to ERM, what is it, 4354, I believe. And we're going to be taking a look at risk financing exercise 5. I hope you were able to understand the fourth one, the previous video. If you have any questions, let me know either in this comment section or the previous one or in the group chat, just let me know. So let's move on to risk financing exercise 5. Excuse me. Um, and you can see that it's a bit different from the monoline. Monoline, you're seeing each individual risk, monoline, and this one is multi-line, where you're kind of making a whole portfolio and having one single budget allocated for it. Now, if you remember, in the instructions, it says you have a $120,000 budget. Let's look at that. Oops. $120,000 budget. Let me find it. Uh, that's 9, 8, 7, 6, 5. Here we go. Here we have, oh, that's 6. Here's 5. You have a $120,000 constraint budget, a premium loading of 30, and that's about it. All you got to do is, why don't we turn these 0, 0, just keep that, and you can see that I've kind of done some computations here on the side. Don't worry about that just yet. But basically, it's just like how we were doing single risk auto liability, general liability. I think there was a workers' comp here as well. It's the same as these three, just doing it here. So how do we figure this out? We have a $120,000 budget. We have annual aggregate retention, and we can see that 29 million is our worst cost. Yeah, that's the worst that could happen in a single year out of these 10,000 years. So let's look at the mean. We can see that the standard deviation is practically 2 million and the mean is practically 6 million. So two standard deviations from 6 million is about 10 million. So why don't we type that in? Oh, and make that a negative 10 million. And 10 million to 29 million is about 20 million difference. Why don't we throw it up to 25 million? How about that? 25 million. You can see that we have not even scratched the surface of our budget. We have a $120,000 budget. So why don't we goal seek this whole thing? Um, and where is that? Goal seek is over here. Goal seek, and we want to change this number to 120,000 by changing our retention. You can see here that we got it. It found it at 120,000 of a budget. We retain almost 9 million. And let's actually do the math. If you do the math, this number, and why don't we, oopsie, take it, uh, hold on, that plus that, you get 33 million, which is above your 29 million. So you know you're fully covered. That math was just to show that this number plus this number is greater than this number. Anyways, getting back to it, you can see here that we have, what's the question asking? Hold on. That's it. We basically solved for that. And you can see what was the maximum reduction in risk? 292. Actually, hold on. I gotta change this number. So yeah, let me fix this real quick. As you can see that I had accidentally copied and pasted this number here twice. But basically, let me solve it with you. We solved for this, and I did the math to find uh this number minus this number. Remember, we're looking in the change of standard deviation, which, let me just make sure, M10 and Q10. Q10. All right, so this number minus this number equals 315,000, which you can copy and paste from Excel into here. And your RF efficiency, remember, is divided by this number divided by 120. So just take that number, copy and paste it. And honestly, you don't need all these decimals. You could actually probably just keep it at 2629. But if you like having 2 decimal points, you can. I'm going to actually cut it off because it can't be rounded up. Bro, that lunch was crazy. Anyways, let me highlight it. I like highlighting it as the answers, but that's what I got. Let me know. It shouldn't be any different for anybody because it's pretty much a standard. This is how we've been doing it. It's a quite easy one. Now you might be looking here and you might be asking yourself, what the heck is this? There is way too much on my screen. And you'd be right. Why don't we take a look at how did we get all these numbers? So, if you look here, total losses HRP, these numbers right here are the exact same as these numbers right here. Can you see that? These are the very same as these numbers. And if you go to the hazard risk monoline, you could see that these numbers right here are also the exact same as these numbers here. So what you need to do for this part of the assignment is you need to take, let's take exercise 5 because we just did exercise 5. If these numbers are the same as these numbers right here, these are the only ones right here changing because we plugged in numbers and we can see a decrease. I asked the question in class, do we add 120,000 to the numbers that we find? And Dr. Miller's answer was yes. You add them to these and you add them to the value at risk. And let me show you what I did. I created just a simple negative 120,000 because that's our expected cost of insurance transfer. That is the money that us, the firm, have to pay the insurance company in order to have insurance. That's the premium. Like you pay for car insurance, that's what the firm is paying for their insurance. So you have to add that to these 3 numbers and this one because it's not included. So I wrote 120,000 right here. And you've got to take your numbers that you calculated, which should be the same for this assignment, and basically just do Q6 right here, Q6 plus 120,000 and do it for each one of these. And you can see I get these 3 numbers and I did it here again for 120,000. I added 120,000 to this number and I got 9.082 million. So now that you have these 4 numbers plus this standard deviation, you can look here on the right that I have 114,000 or 1.114 million. 1.114 million. That this number matches that number. Or I'm sorry. I apologize. I actually didn't even add that. Look at this. This is the mistake you don't want to make. Hold on. All right, everybody. I corrected myself. As you're gonna see, this video has like very minimal editing. But if we look at the multi-line now, excuse me, you could see. Let me zoom in real quick. That these numbers on the right, these numbers right here, I've added 120,000 to. This number has 120,000, this one has 120, this one has 120, this one has 120. Only the standard deviation, it does not increase by 120,000 because it's not a monetary number. It's not a dollar amount. So do not change your standard deviation for any of them. So as you can see, these 5 numbers are these 5 numbers, including the standard deviation right here. Now, what you want to do is go to Multiline and do the exact same thing. We calculated an exercise for $60,000, $60,000, $0. And you're going to take these numbers on the right. You are not going to have these numbers, but I want you to calculate them. Take these numbers and add 120,000 to them. Do not touch standard deviation. So you're going to take this number, see how it's the exact same here. See how this number is the exact same here. See how this number is different. This number right here, these two are not the same because I added 120,000 to them. And you can see this number does not equal the exercise 5 one, and that's fine because that's how it's supposed to be. And you're going to see if you do this across all of them, even if you do exercise 3, you got to remember exercise 3's numbers. If you don't remember exercise 3's number, all you got to do, remember, is go to Goal Seek and change it. Remember, you had a $40,000 budget for all of them, so you're going to take this one, 40,000. I'm doing this live, so I'm showing you how easy it is to do. Very simple. Done. Go to the next one. What if analysis? Goal Seek. Change this one. 40,000. I'm doing it right here in front of y'all. This is pretty much live. And retention. Remember, change the retention. Boom. What if analysis? Goal Seek. Change this. This one. 40,000. Change retention. And you can see here, after I've changed everything, take these numbers and add 120,000 to them. You can see here, don't add standard deviation, and you see it's the exact same right here. 8925. Ooh, actually, I have to change this. I had made a mistake. Command C, Command V. That's all you got to do. Just copy and paste. Let's see, 1234, 196. That's correct. This one is correct. 14 million here. That's correct. And that's it. That's all you have to do for this chart. And what I like to do is you can actually, make sure to, I like to have close these gaps up just so that the chart gets smaller. As you can see here. And then I like to highlight everything so that it's easier to read. Boom. And then let's look at the last problem. I believe that's it. Let's look at the last problem. Which risk financing approach is more efficient? How do we know, based on all this number calculation, that what we did was efficient or not? And you can see here, if we look at the standard deviation, the lower the standard deviation, the less volatile the impact of loss will be on our firm. So you can see here from exercise 3, when we had 40,000 per individual risk, we had 1.62 million standard deviation. You could see through exercise 4, when we split 120 among the 3 risks, but not exactly the same amount, we chose whatever amount, 60,000, 60,000, 0, you could see that the standard deviation decreased, meaning it was more efficient. But buying a multi-line policy, doing a multi-line policy where we just had we only had one budget for everything, means that in this example, it was more efficient. It was more efficient than all of them. 155 or 1.57 million is lower than 1.62 and 1.6. You could see that it was much more efficient. So, which financing approach is more efficient? So which risk financing approach is more efficient? It would have to be your multi-line policy, because if you look here, your multi-line is higher. I hope you enjoyed.